When we have polyatomic ions, we simply insert the name of the ion where it should go in the compound's name. But first, let's define oxyanions. Oxyanions are polyatomic ions that contain oxygen, and we really should memorize the most common oxyanions: the bromate ion, the iodate ion, the chlorate ion, the nitrate ion, phosphate ion, sulfate ion, and carbonate ion. You're actually going to make your life a lot easier if you memorize these most common oxyanions, because if you know all of these, you can name many other variations of these based on a naming convention rule. Notice that I've grouped all of the something O3 minus together. Then we have the phosphate, sulfate, and carbonate ion. Those need to be memorized. If an oxyanion differs from the above by the number of oxygen atoms, the name changes are as follows. The most common name was always 8. On the previous slide, you might remember bromate, iodate, chlorate, nitrate, sulfate, phosphate, carbonate. That would be right here in the most common. If there's more oxygen than that, if there's one more, then we would say per8, per sulfate, per phosphate, per carbonate. If there's one fewer, we say ite, nitrite, or bromite, or iodite. If there are two fewer, we say hypo, hyponitrite, hyposulfite, and so on. Let's try a few examples. Let's write the formulas for these compounds. Iron 3 nitrite. Iron 3 ion looks like that. Nitrite. Well, what's the most common that's related to this? Well, that would be nitrate, which is NO3 minus. But nitrite has one fewer oxygen, so its formula is NO2 with a 1 minus. And what's the ratio of these? Clearly, I'm going to need 3 nitrites to cancel my 1 iron. So we write it like that. Ammonium phosphide. The ammonium ion, we're supposed to have that one memorized. Phosphide, from the periodic table, we can look up phosphorus. It's element number 15. It would tend to gain 3 electrons, which means it has a 3 minus charge. Here we're going to need 3 ammoniums to match up with our 1 phosphide ion. How about ammonium chloride? Well, there's our ammonium ion again. Now chlorite, let's see. That's related to the chlorate ion, which we've memorized. Chlorate is ClO3 minus. So chlorite is ClO2 minus. Notice that when we go from 8 to ite or hypoite or per8 by changing the number of oxygens, what we don't change is the charge. So chlorate is ClO3 minus. Chlorite is ClO2 minus. Hypochlorite is ClO minus. So you don't need to worry about changing the charge. The charge always stays the same. It's the number of oxygens. So ammonium chlorite will have that formula, NH4ClO2. What about zinc phosphate? Zinc is a fixed charge cation. We're supposed to know that its charge is going to be 2 plus when it forms a cation. Phosphate is PO4 3 minus. So we're going to need 3 zinc ions and 2 phosphate ions to make this a neutral formula. And lead permanganate. Permanganate is one of those ions that I've asked my students to memorize. There's the charge on lead 2. Permanganate is MnO4 1 minus. So we're going to need 2 permanganate ions for lead 2 permanganate. Now let's write names. This first one is going to be ammonium, and the second part is sulfate. Nothing else. How about this next one? Silver and BrO3. Well, BrO3 is bromate, so silver bromate. How about this next one? This first one is called ammonium, and then this is the nitride ion, ammonium nitride. Now, what about this one? On this periodic table in the upper right, uranium is actually not shown. It's down here in the F block. It's element 92. But all of those are variable charge cations, which means we need a Roman numeral when we write the name out in English. So that means that we need to find the charge on each uranium ion in that formula. So here's what we're going to do. We're going to write out, that's called the chromate ion. My students are supposed to have that one memorized, and the formula shows 3 of those ions, which counts up to a total net negative charge of 6, which means that one uranium must be worth positive 6. Therefore, the name of this one is going to be uranium 6 chromate. Similarly, for this last example, we have chromium, which is element 24. Chromium is right in here somewhere. So it is a variable charge cation. So when we write the name, we need a Roman numeral that tells what charge those ions have. I'm showing my work here. I'm trying to walk you through my thought process. We've got SO3 ions, which would be called the sulfite ion, because sulfate, that's the most common one, is SO4 2-. So this is SO3 2-, which is sulfite. Remember, the charge doesn't change when we go from 8 to 8 and so forth. So it has a 2- charge. All of this sulfite gives us a net of 6 negative charges, which means each of these chromiums have to be worth 3+, so the name of this is going to be chromium 3 sulfite.